Hey all. So here we're going to do a little bit of fitting something that's not a line through some data. So I promise this is actually like not really different. The principle here is exactly the same. So my goal is I want to fit a parabola through these six data points, right? So I'm just going to write down what it means to be on a parabola as my first thing. So I'm going to write down a parabola kind of generally here as c plus dt plus et squared equals b, right? And then I'm just going to go ahead and put my data points down. So my first data point is going to be c plus d times 0 plus e times 0 squared, and that's going to equal 6. And my second data point is going to be c plus d times 1 plus e times 1 squared equals 0. Right, so I'm just getting my t's out of the first slot and my b's out of the second. So I'm going to go through and keep writing each of these. So I got c plus d times 2 plus e times 2 squared is equal to 0. And I have c plus d times 3 plus e times 3 squared is equal to 4. Oops, crap. That was supposed to be a 2. And c plus d times 0 plus e times 0 squared is supposed to equal 2. And c plus d times -1 plus e times -1 squared equals 5. Okay, bit much, but not too bad. Now, the easy thing here is I just want to write a matrix equation, right? So my matrix equation is going to look like this. I got coefficients on C's. 1, 1, 1, 1, 1, 1. I got coefficients on D's. 0, 1, 2, 3, 0, -1. Notice that column is literally just the x values out of my data, right? The first column was the x to the zeros out of my data, right? The constants. The second was the x to the first powers. And then this third one is going to be all of those x's squared. So I got 0, 1, 4, 9, 0, 1 for my second column here. And then this is supposed to be multiplied by some vector here. That's the vector CDE. And then this is supposed to output the vector 600425. And my guess is that this just probably doesn't work. I have a pretty good reason for that. My reason for thinking that is here's my data. That shit ain't on a parabola. How do I know that's not on a parabola? Well, 0, 6 and 2, 0 are over top of each other, right? So whatever function I try to draw here, if I hit all the data points, it can't be a function. So I know right now because of that relationship, right? The fact that I have two lines with a 0 as the input and different things as the output means that this can't be a function. So what that means is that the b here that I'm looking at, right? Remember, I'm thinking ax equals b. This b is not in the column space of that matrix A. So I'm going to project it. I'm going to use exactly the same formula I was using before. So I'm going to use x hat is A transpose A's inverse done to A transpose B. And this one's too annoying for me, so let's punch it into Desmos. So I've got my Desmos matrix calculator over here, and I just need to punch in this matrix. So it's 1, 0, 0, 1, 1, 1, 1, 2, 4, 1, 3, 9, 1, 0, 0, 1, -1, 1. And my matrix B, right, that vector, is a new matrix, and that thing is 1 column and 6 rows. Oops. And that guy is, oops, I guess I'm gonna have to read it right here. So that's 600,425. And then I can go ahead and calculate my x hat. I need parentheses, A transpose A, close my parens, inverse, A transpose, and a B. So I got this guy. All right, what does that mean? So I'm going to write that. Actually, you know what? What the heck? We're on a computer. Oh, actually, let's convert that to a fraction, which is real gross. So what I got here is this is my x hat. Okay, now what do I do with that? Well, remember, that's the best I could do solving for x. So that means that my parabola is given by 43 sixteenths minus 407 160ths times, oops, that's not an x, times t plus 29 32 times t squared equals b. So our next step is we're going to plug this in to Desmos and just double check that it looks like. So I punched that in, and here's what I've got. That actually looks pretty decent, honestly. It's not going through any of the points, actually, but if I had to have guessed what a parabola through that looks like, that is pretty close to what I would have guessed, which is always interesting, right? That humans are actually pretty good at this. And what this did was this minimized the displacement, right? In terms of distance, right? So this square sum of all these displacements is what got minimized here. So ultimately, I've found my best fit parabola. I'm happy with that. I can circle this thing and move on with my life. Thanks for watching. Have a good day.